Okay, so before we jump into the four-way handshake, I wanted to take this extra topic of discussing with you about master keys and temporal keys. Okay, this is usually not the fundamental topic, but I want to. This is an in-depth topic about how the keys are really generated after the heap, and I wanted to cover this so that you have a better understanding of what's going to follow. That's the four-way handshake. Okay, so till now we have done how heap is done, how heap is processed, and what you need to know now is that after heap is finished, the byproduct that comes out are some keys, right? We've discussed that some keys are formed after heap is done. So the first key that is generated is called the master session key, okay, which is also called as the MSK. This is the master session key, also sometimes known as the AAA key. This is just another name for the master session key, also known as the AAA key, right? Now this can be generated either after 802.1x or even after PSK. So the MSK, that is the master session key, can be created after successful authentication in .1x or pre-shared key, right? So now when EAP, we've already done this, that when EAP is deployed, both the authentication server and the supplicant will know information about each other after the mutual authentication of credentials, right? Basically, the supplicant knows about the certificate, and the server knows about the username and the password of the user, right? So that's how they know about each other. So both authentication server and supplicant, they are familiar with each other. They know about each other via the exchange of credentials, right? Now this MSK, which is formed right after EAP, is the keying material that is derived from the process of EAP. That's pretty much what we've discussed. And now it is sent and stored on both authentication server and the supplicant. So MSK is stored on the authentication server and the supplicant. Okay, this is something which you should know, and it is basically at least 64 octets in length. This is the MSK, which is the master session key. Okay, now let's discuss about some master keys. So master MSK was the first key that was created after EAP, right? So after the creation of MSK as a result of EAP, two master keys are, so there are two more keys which are generated from MSK. Okay, I know it's a little complicated, but try to catch up. So EAP MSK gets created. Now from MSK there are two more master keys that are generated. Okay, now these two master keys are basically called PMK, and I'm going to talk about the second one later on. Now the MSK is now, which coming from EAP, the MSK now becomes the seeding material that is used to create the PMK. The PMK is called pairwise master key. Okay, PMK is called pairwise master key. Okay, this is called pairwise master key. Now again, a PMK also now resides on both the supplicant and the authentication server. Also resides on both the supplicant and the authentication server, right? The pairwise master key is basically kind of like, it actually is, I mean, effectively it's a portion of MSK. Okay, the PMK is more or less the portion. Effectively it's the portion of MSK itself. Okay, that is something which you should know. So a unique PMK is generated every time a client authenticates or re-authenticates with an access point. So a unique PMK is generated every time a client authenticates or re-authenticates, right? That was Now that is PMK for you. Okay. Now the other key, the other master key that is created from MSK, the master session key, is called the GMK. Okay, that is GMK is basically group master key. Okay, now this one is randomly created on the access point and the authenticator. Okay, this is randomly created on the AP and our authenticator. Okay, this is randomly created. Now basically keeping in mind that master keys are not, I mean, you need to keep this in mind that PMK and GMK are not the keys that will encrypt the .11 frames. Okay, still we are not there yet. So E brings in MSK, MSK will bring in PMK and GMK, but these two keys are still not there. These two keys are still not used to encrypt and decrypt the unicast frames of the .11 exchange, right? Now after this, the four-way handshake happens. Okay, and that's when the temporal keys are created. Temporal keys are created. Okay, now PMK, I'm sorry, yeah. Now PMK, let me just correct that, sorry. Anyway, PMK will become or will give rise to PTK, and GMK will give rise to GTK. We will discuss about this in the four-way handshake video also, but PMK is what converts or gives rise to PTK, which is called pairwise transient key. Okay, it's called pairwise transient key, and GMK gives rise to group temporal key. Now these two keys are the keys that are used to encrypt the .11 transmissions. PTK is used to encrypt and decrypt unicast frames, whereas group temporal key is used to encrypt and decrypt multicast and broadcast frames. Okay, so this is how we arrive at the final keys which are of use to us, which will basically be used to encrypt and decrypt the unicast .11 or unicast or broadcast multicast .11 transmission, right? Now I think we can move to four-way handshake in the next video. Now I think it's going to make much more sense for you to understand how this four-way handshake is done and how PTK and GTK are really created, right? See you in the next video.